Good afternoon, everyone. This is Yelishetty Priya Nagasai, enrollment number E20CSE188 from batch EB11, here to present the topic reinforcement learning. I chose this topic as I'm very interested in human psychology and machines' cognitive abilities. Today, we will see Introduction to Reinforcement Learning, relationship between computers and human psychology, how we can apply the same logic on our systems to make them behave like humans. We will also see reinforcement in the field of artificial intelligence and how reinforcement works. Reinforcement, according to Google, means the process of encouraging or establishing a belief or pattern of behavior. It is the process of strengthening certain habit, be it positive or negative. It works similar to Karma Siddhant of our Sanatan Dharma, where we imagine Chitragupta writing all of our good and bad deeds, calculating the score to figure out if we really deserve something or not. Now that we know what reinforcement means in general, let us try to connect it with our domain. As we all know, the broader domain is AI, followed by ML, which is then followed by DL. But there is also another pre-existing domain called as RL, also known as reinforcement learning, which many of us know by its name, but it's really never entered the limelight. RL is a subdomain of machine learning and is a sibling of DL. Machine learning can be categorized into deep learning and reinforcement learning, where each of these subdomains focus on different learning patterns. DL uses training data and then applies to new data set, whereas reinforcement learning learns by adjusting actions based on continuous feedback to maximize a certain reward. We can also categorize machine learning on learning patterns like supervised, unsupervised, and reinforcement learning. In supervised learning, the machine trains on labeled data, which can solve classification and regression type of problems. It maps the labeled input to the known outputs. During unsupervised learning, the machine trains on unlabeled data without any external guidance. It solves problems related to association and clustering. It understands patterns and discovers output. But in reinforcement learning, we have an agent who interacts with the environment by performing actions and learning continuously from its errors and rewards. There is no predefined data and follows a reward based problems. It follows trial and error method. Reinforcement learning is inspired by human behavioral psychology, neuroscience, maths, and computer science. To visualize what reinforcement learning is, let us focus on this scenario. Imagine a dog being presented with food. Let us also assume that we have a bell. Before conditioning, the dog comes towards the food whenever it is hungry. It is curious about the bell. Once we start his conditioning, we ring the bell and present him food every day for a couple of weeks. For the initial days, he was found to be confused by the bell, but felt happy when he was presented with the food. He didn't eat the food until he was hungry. The bell was rung during specific hours and had a pattern. Slowly, as the days progressed, it was noticed that as soon as the bell was rung, he started salivating, even though he wasn't hungry. It was also noticed that he started looking for food in those specific hours, as now he was our conditioned agent. There are total four types of reinforcement. Positive reinforcement means that we reward the agent when they do something desirable. We give them something in exchange of the action. It's similar to getting praises when we get high marks in front of everyone in your class. Negative reinforcement is the opposite of the set case. Here, we punish the agent to do something they weren't supposed to do. The majority of parents do this unknowingly to their kids when they get less marks in the exam by scolding them. The third type is called the punishment. This is extreme case of negative reinforcement. Here, for example, we give no food to the said student or the dog who received less marks or has misbehaved as a form of punishment. The fourth one is called extinction, where we ignore the agent for doing something wrong. If we consider a dog who has peed on the couch, instead of being angry on it, its owner starts ignoring the dog so that the dog understands where it went wrong and starts feeling bad by itself. Basically, as it's written, we allow our intelligent model to freely explore the environment and take actions in that controlled environment to maximize rewards to do the right thing. Let us visualize this. In reinforcement learning, we have agent, environment, and a final stage. Imagine, in the first stage, the agent tries to navigate through the maze and fails. He is sad and also gets punished for the same. The agent tries for n number of times and fails each time before he reaches the other end. He gets punished or denied or is denied rewards every time he fails. In the final stage, he reaches the end and is rewarded. He now has explored the entire maze, knows exactly where to go and where not to go, which way would lead him out of the problem. As discussed, reinforcement learning playground consists of the environment, reward, agent who is allowed to explore, learn, and train. Once the agent has learned, we confirm the policy of the agent and also deploy it into the output. This is an application of RL to classify raw data into three classes by hit and trial method. It creates a policy by itself using the reward punishment action and algorithm. This is the code of OpenGym AI where we render a cart pole using the said environment. We create action space, reward, information for doing the following action of rotating the cart pole. We break the loop if the model knows what rewards him and what does not. In this, we save the policy that the model is following and then we use it in the reinforcement field. I hope I made the topic of reinforcement learning more interesting for everyone present here. I'm open for questions and I'm glad I could interest you with this presentation. Thank you.